All right. So I realized that although my microphone is working better, everything that I did was on the board was backwards, and I don't know how to flip it. I'm not sure why it did that. So hopefully the sound is good, and now you will be able to see everything behind me. I can't see myself, so hopefully I won't be writing outside of the boundaries, but we'll give this a shot. All right, so we are on number 6, okay? So now we're gonna be practicing using our new equation, which is gonna be molality, okay? Molality is just moles of the solute over kilograms of the solvent. So number 6 says, if a solution is made by mixing 50 moles of KOH to 3.4 grams of water, what is the solution's molality? Okay, so they gave us everything we need. Okay, I'm just going to rewrite my equation right here over number of kilograms. Okay, so they gave us moles, they gave us kilograms. They were really nice. So we're just going to plug those in. 50.0 moles over 3.4 kilograms, okay? So when I crunch these numbers out right here, I'm gonna end up with 15, and keep in mind, moles over kilograms, that is little m, okay? So that's what we're solving for. So really, and for this one, it's just a matter of plugging those numbers in, okay? They're really kind. Let's do the next one. This is number 7. Number 7 says, if a solution is made by mixing 35.0 grams of CaBr2 with 657 grams of water, what is the solution's molality? So we're looking for molality again. They gave us grams of one and grams of another, which is a little bit annoying, but it happens. So that doesn't help us right here, but we can go from grams to moles here and grams to kilograms here. So let's go ahead and do that. The first one they gave us was 35.0 grams of CaBr2. So we can take that number and we can switch to moles, okay? Grams of CaBr2. All we have to do is look on our periodic table and find our AMUs. So if I add together my AMUs, I have 199.9, okay? And that's going to crunch out to 0.175 moles, okay? So we found our first top number. Now, in kilograms, they gave us 657 grams, okay? So we can really easily switch over to kilograms like this. So really, I'm just moving my decimal point, 657 kilograms, okay? So now I've got my moles, I've got my kilograms, I can go ahead and put those into my equation. So I've got 0.175 moles over 0.657 kilograms, okay? So if I plug that into my calculator and I crunch it out, I'm going to end up with 0.266, and then remember, moles over kilograms is just molality, okay? So if you're able to do these just fine, that's awesome. Really, it's just plugging numbers into this equation, and sometimes you have to convert a little bit before you do that, okay? So let's move on. Numbers 8, 9, and 10 are all going to be similar. We're going to be dealing with boiling points and freezing point depression, and we're going to be using our new terms to our molality to help us with that, okay? So number 8 says, if you want to lower water's freezing point by 5 degrees Celsius by adding NaCl, what must the molality of the salt solution be? So whenever I do these, we're going to be using these two right here, and they're very, very similar. There's just a negative in front of the I, and instead of being freezing, it's boiling right here, okay? So I'm going to go ahead and list out everything I need. I need an I need my K, and in this case, it's going to be F for freezing, molality, and then I'm going to add my delta T here, okay? So before I plug them into my equation, I'm going to just make note of what I've got, okay? So the first thing they gave you is they're always going to give you your KF or your KB. So in this case, it is 1.86 degrees Celsius molality, okay? And they said what must the molality of this be? So in this case, we're going to be searching for this, okay? So that means they must give us a delta T. So sometimes we'll be solving for the delta T, and sometimes we might be solving for this, probably not for this. So it's usually one of these two, okay? So if I need to find I just need to take a look. They said NaCl. I realize this is an ionic compound, so I'm going to split it and see how many ions it breaks down to. That's what my I is, okay? So this is 1 and this is 1, so together that's 2, okay? And lastly, my delta T, they said that they're lowering the water's freezing point by 15 degrees. So if it lowers, it's a negative number, so I have negative 15 degrees Celsius, okay? So now I'm going to write out my equation, which is delta T equals negative I times Kf times M. Now, in this case, I'm not solving for delta T, so I'm going to rearrange my equation to solve for M, okay? So I'm going to use algebra to do that. I'm going to divide by negative I times Kf on both sides. So they cancel here, which is an M that I'm left with. Okay, so I'm just going to rewrite this quick so it's a little bit cleaner. Okay, now I've got everything I need. I can go ahead and plug it in. Okay, so my delta T is negative 15 degrees Celsius. My I is 2, so I've got negative I times 1.86 degrees Celsius over molality. So you can see my Celsius unit is going to cancel, which is good because that's what I'm really looking for, is that little M. So if I multiply these two and then divide top to bottom, I'm going to end up with 4.0 M. Okay, that's what I needed to find right here. So really it's just a matter of, they usually give you this number. You're either going to solve for delta T, and you're going to have to find out if it's an ionic compound. You're going to split it. And if it's covalent, remember, it only breaks down by the molecule. We'll probably go over one of those. And then you just plug in your numbers and figure that out. All right, I'm going to stop here, and then we will do the last two. All right, so we are on the last two problems, 9 and 10, of practice problems for Module 11. All right, so I'm going to read number 9. It says, what is the freezing point of a solution made by mixing 35 grams of NH3 with 350 grams of water? So like we did with the last one, we're just going to plug in what we know, okay? So they gave us the Kf, which is 1.86 degrees Celsius molality. And then we need to find the molality and the I. So if I take a look right here, NH3, N and H, nitrogen and hydrogen, are both nonmetals, which means that they are a covalent compound. So they're not ionic. So when this breaks down, it breaks down as one whole molecule, okay? So really I'm looking to see how many of these molecules do I have? I just have one because there's no number out front, okay? So that means my I is going to be the number 1. All right, so the last thing I need to do is find out my molalities. They gave me grams and grams. So I'm going to go ahead and off to the side, I need to find M. Remember, it's moles over number of kilograms, okay? So they didn't give me either of those things. That's okay. I can use my grams of both to find it, okay? So I'm going to start with 35.0 grams of NH3 over 1.
Well, it's probably too late now because it's his birthday.
1 mole, and I'm going to use grams. And I'm going to find my AMUs right here. So if I use my periodic table to do that, I'm going to find it's 17.0. So I am going to get 2.06 moles, okay? So that's going to be my top number. Now I need to find kilograms. They gave me grams 350.0, so I know that's going to be kilograms right here. 0.3500 kilograms. So I'm going to just go ahead and plug these in to find M. So I've got 2.06 moles on the top and 0.3500 kilograms on the bottom. So I crunch these in my calculator and I end up with 5.89. And remember, moles over kilograms is little m. So I'm going to plug that in right here, 5.89 m. So now I can go ahead and take my equation, and I'm solving for delta T. So delta T equals -1, then I put this number in, 1.86 degrees Celsius over molality, times my m, 5.89 m, okay? My m's are gonna cancel. I'm gonna multiply out all those numbers, and I'm gonna end up with -11.0 degrees Celsius is my change in temperature. Now, that is not your final answer. You always need to check and see what they asked, okay? They asked, what is the freezing point of this? So remember, this is just change in temperature. And since we were dealing with water, we know water freezes at 0 degrees Celsius, okay? So if I just subtract 11, we know that my actual answer is the same as this one. It just happens to be that it's actually -11.0 degrees Celsius. That's the temperature that water freezes at, okay? All right, let's look at the last one. Let's erase all this. Number 10. Okay, number 10 says, what is the boiling point? Okay, so I'm just gonna go ahead and change that. Now we're dealing with boiling point. It says, what is the boiling point of a solution made at 100 grams of ZnCl2 with 750 grams of water, and the KB for water is 0.512. Okay, so we're going to do the same thing. Start by plugging everything in. They gave me this one. It is 0.512 degrees Celsius molality, and I need to find my I. Let's see, I have ZnCl2. So this is ionic. So I'm going to go ahead and separate it. I've got one ion, it breaks down into here, and chlorine, there's 2 of them. So that's a total altogether of 3. So that's my I is 3. Now I need to find my M. They gave me grams and grams again. So that's fine. Over here, I'm just going to go ahead and switch the 2. So I've got 100.0 grams of ZnCl2. Okay? Multiply that. And ZnCl2. So if I go to my periodic table and I find this, it's going to be 136.4 grams. So if I crunch this through, that's going to get me my number of moles, which is 0.7331 moles. Okay? Because we're trying to find M. Remember, moles over number of kilograms. So we just found moles. Now we need to find kilograms. They gave us 750.0. So I know that the kilograms is going to be 0.7500, because I can do that in my head now because we've done chemistry for a while and math. All right, so let's go ahead and plug those in. M equals 0.7331 moles over 0.7500 kilograms, okay? So if I crunch that through, I am going to end up with 0.9775. Remember, moles over kilograms is just a little m. So this is my number up here. I'm going to plug it in, 775 m. Now I can go ahead and erase this for space, and I'm going to pull my boiling point elevation. It's almost exactly the same. Delta T equals, I'm going to plug in my I is 3. I'm going to plug in my KB is 0.512 Celsius molality. And then I'm going to plug in my molality is 0.9775 molality. My little m's cancel. If I crunch this through and multiply it, I get 1.50 degrees Celsius is the change in temperature. And then I'm going to double check and see what did they ask. They said, what is the boiling point of a